Right, let's do this. Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm a managing director at InRhythm, and we have a lot of content lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants speaks on the latest and greatest technology trends in the industry that will help you keep learning and growing in your career. And this week, we have Austin Michael, who is the director of engineering, and he leads our mobile practice. He's going to talk about server-side Swift. You all know that Swift is an excellent general purpose programming language. And I'm looking forward to see what the unique characteristics that make Swift specifically suitable for the server-side applications. So without further ado, let's get it started, Austin Michael.
Awesome. Thank you, Parag. So like Parag said, I am Austin Michael Komatz. Here at InRhythm, I am the director of the mobile practice. So overseeing all of the iOS and Android teams across InRhythm. Today, I'm going to be talking about a really exciting topic, which is server-side Swift. This topic has been a long time coming. I've been really looking forward to giving this talk. Last time I did a lightning talk, it was on Swift UI. So I'm really excited to be talking about a backend technology now. So without further ado, let's go ahead and jump in. So I want to just start by talking about Swift. Swift, many of us work with it, especially in the mobile practice daily, whether you're working as an engineer or you're working as an automation engineer on the QA side, you're doing a lot of work with Swift, and it's usually going to be on the iOS side. But I want to challenge that today. So Swift is a general purpose programming language. It's not meant specifically for one specific platform. Like iOS is a very typical platform for Swift, but it can be run anywhere. And we'll get more into that in a minute. Swift was released by Apple in 2014. It is open source. It's written in C++. It is a compiled language. And again, it is available on most platforms, including iOS, macOS, Linux, and Windows is a new addition to Swift's availability, and more. So I really want to hone in on this one area right now, available on most platforms. It is not a technology specific to iOS or macOS, right? It is not a language for only making iOS apps. Swift is a very versatile language that can be used in a wide variety of applications. So today I want to talk about server-side Swift. Specifically, I want to introduce Vapor, a server-side framework for Swift. Vapor is very popular in the server-side Swift community. There are other alternatives I'll get into later, but Vapor is widely renowned as the best, most used server-side Swift framework. So let's talk a bit about Vapor before we hop into a demo. Vapor is 100% written in Swift. It allows building APIs, services, backends, and websites. It's a non-blocking, event-driven architecture built on top of Swift NIO. And one of the greatest parts of Vapor is it's protocol-oriented. So very modular, very scalable. And of course, along with Swift, because Vapor uses Swift, it's a type-safe framework. It's also open sourced, introduced in 2016, so relatively new, and it was created by a third party. I want to talk about a couple topics today regarding Vapor. Specifically, we're going to talk about databases, HTTP, general HTTP networking. We'll talk about authentication, and we're going to get kind of advanced today and talk about WebSockets. So super exciting. Let's start with databases. Vapor supports a whole lot of databases, as you can see here. So we have, of course, Postgres, we have SQLite, MySQL. We also have NoSQL solutions, such as MongoDB. and Redis. So in this example, we're actually going to be using Postgres and Redis. But the point here is basically whatever database you want to use, Vapor has a solution. I know there are other databases that aren't included here. There are third-party frameworks not developed by the Vapor team that are available as well. So let's hop into the demo. So what I have here is I have two simulators running here. Running an app I'm calling Lightning Chat. In this chat, it's essentially just a real-time chat application. So I've here redacted my email and password. I'm going to go ahead and sign in. I'll also sign in on this device. Oop, I typed that incorrectly. Okay, so then I'm taken to this dashboard where I can join a thread. This is actually a text field. I can edit it, whether I want to join thread 1, 2, 3. I'll just stick with thread 1 for now. So I'll go ahead and press join on both. And you can see here, I can type between the applications. So if I send a message here, it automatically pops up over on the other device because both of these devices are connected over a WebSocket to the Vapor application, which is using Redis and allows for real-time chat. So again here, how are you doing? Send that and it appears immediately just like that on the other device. So real-time chat application, nothing super special. What is special is the technology behind it. So let's talk now about Vapor and actually look at the code base. What does it look like? First thing you're going to notice is this is a Swift package. It is not a typical like Xcode project or Xcode workspace. It's not using CocoaPods or Carthage. It's using Swift Package Manager. So what that means is you can take this package and deploy it anywhere, whether it's Heroku, AWS, Google Cloud, Azure, all of these different providers, all of these different cloud providers have the ability to easily deploy one of these Vapor packages, especially on Heroku. Typically, whenever I've developed a backend solution in Swift, I've deployed it on Heroku because it's like really, really simple. So we can take a look at the Swift package. Again, it's your typical Swift package. Here we add the Vapor code base, or the Vapor package. We add the Fluent package, which is for querying databases. Fluent is the ORM in this example. We add the Fluent driver for Postgres. We have a JWT library for authentication, Nimble for testing. We have Redis and WebSocket Kit. So very simple. It's your typical Swift package. So I want to start by talking about the models, right? Working with the database, what does that look like? So I'm going to come over here into this user object. Specifically, I'm going to focus on this portion right now. Here we have our user class. It conforms to the model protocol, the content protocol, and the authenticatable protocol. So Vapor is, again, very protocol oriented, very composable. There's no inheritance whatsoever. It's all driven by protocols, so extremely flexible. So this is our actual model. We define the name of the schema we want to use, in this case, users. We add the primary key, which is the ID, and it is of type UUID. We add the Firebase ID. In this application, we're using Firebase auth to authenticate, and then the backend validates that the Firebase tokens against Google's JWKS. We have a field for the email, some timestamp fields, and a convenience initializer just for easily creating a new user. And that's it. That's how you create your database model. There is one extra step to create your database model, and that's by creating a migration. So this migration is called create user table. In the prepare function, we will say database.schema, pass in this same schema name that we used up here. The ID field, a field for the Firebase ID, it's a string, it's unique and it's required. The email field is a string and it's required. And then we have a field for created at, updated at, and then we create it. We also run some custom SQL here to create an index on the Firebase ID field so that we can easily access or easily find a user based on their Firebase ID from their token. So while we do have like an ORM here, you can also run raw SQL. And that's it as far as models. I can, I'll quickly just pull over my Postgres GUI here, and you can see I have my Lightning Talk database here. Here is my users table, and here are the 2 users I have. These migrations will automatically run. You can configure it to automatically or manually run, depending on your needs. Right now, these migrations automatically run when you launch the application. So we talked about databases. Now let's look into routing and configuration. So on app launch, this method is going to be called configure. What this is going to do is it's going to configure the server address. Right now I have it on localhost port 8080. It's going to configure the JWKS, the routes, the migrations, database, Redis connection, and some extra middleware. So let's jump into the route section. Here is where we configure our typical HTTP our typical HTTP endpoints. So here we have a quick little endpoint just for a health check. Here we register our service collections. So I have 2 collections right now, user service and chat service. We're going to first jump into the user service. So when we register the service, it will call this boot method, which is where we actually determine where we want our endpoints to live. So the register service is going to live at /user/register, and it's a post method. When someone hits that endpoint, it's going to use this function. It's going to, all of these endpoints are going to take a request object and return something. In this case, it's going to return a user. What I want to highlight here that's really cool, and it's also relatively new to the Vapor framework, is the support for async await. So previously, when using Vapor, you had to use a lot of like closures, kind of like combine, like a lot of flat maps, a lot of maps, and syncing for when things complete. But in this case now, we have async await available to us. So it makes it a lot simpler and a lot cleaner. So in this register method, we check for the bearer authorization token. And then what we do is we verify it against our expected JWT payload. So I'll jump into that in just a second. Then we try to find that user. So here we are actually querying the database. So user.query on request.database, filter Firebase ID equals payload.firebase ID, right? So this is how we can easily filter using Fluent. And we take the first entry. If it is not found, or sorry, if it is found, we know the user has already registered. So they shouldn't be calling the register endpoint. So we just throw an error in that case. Otherwise, if the user hasn't been created, we create the new user object using the Firebase ID and email, and then create it on the database. So user create on request.database. And then we return the user, and it's returned to the client as a JSON object automatically. There's no extra encoding or anything that we need to do. We just return the user object, and it will be converted into JSON and sent back to the client. And that's it. So that's our register endpoint. Let me jump into this JWT payload. So on the user, we have a struct called JWT payload, and it has your typical JWT fields, including issuer, subject, audience, issued at, expiration, and some extra fields from Firebase. Here this is where we decode it. I'm not going to jump into that, but here this is where we actually verify the token. So here we get the issuer from the environment. We get the client ID as well from the environment. We verify the issuer. We verify the expiration, the audience, and issued at. And that's it. Now at that point, our payload has been verified and we can use it. Then what we can talk about is middleware, right? So obviously we don't want to do this manually for every endpoint. Here we do it manually because it is a registration endpoint, so we have to go and get the user, check if it exists or not. There's a bit of extra logic here. But on this endpoint, the get user current, to get the current user, we have this middleware which automatically will authenticate the user. So it'll take the authorization token, compare it as the payload, and then get the user. If the user doesn't exist in this case, it will throw an unauthorized exception. And then on the request, it will log in the user. So we can easily use it in this get current user method. Let user equals request auth require user.self. And then we can just return the user. So that's the basic HTTP service side. Now let's get into the more interesting side, which is WebSockets. So for that, we'll come over to the chat service. The boot method is pretty similar. So on the routes object, we call grouped, pass in the auth middleware, and then the WebSocket. So instead of get or post or put, we use WebSocket. And it's going to, the client will connect to the /chat endpoint. And when it gets upgraded to WebSocket, it's going to call this connect method. Here in the parameters, we take a request, we take a WebSocket, and then basically just add some completion handlers or some closures to handle the different events on the WebSocket. So when the WebSocket receives some binary data, it's going to execute this. When it closes, it's going to execute this. We also, I'll get back to Redis in just a moment. So when we receive some binary information from the client, what we're going to do is decode this client event object. This allows us to, essentially we have the JSON structure, it looks something like this. So we have event, and this could be send message, and then data, and this is our actual object that we want the WebSocket to receive. So this can be, for example, down here we have message, and this could be, hey, how are you? So there, that's the structure of our JSON that we're decoding here. We could have different events like heartbeat if we want to see if a user's online, or maybe if a user edits a message. Yeah, this allows us to dynamically determine what information is being sent over the WebSocket. So we decode the event and then basically create a new message object and send it, and we encode it into JSON and send it to the Redis channel. So we publish it over Redis so that any other listeners receive that message and can broadcast it to the client. And that's it. So then in our Redis manager, we subscribe to the specific channel that the user requested. So over here, if you type in thread 2, we will subscribe to the thread 2 channel. And when we receive an event on that channel, we will send it back over the WebSocket. So we'll send it over the WebSocket. The client will do a similar operation to decode and then display it in the chat. And that's it. So now we have our HTTP, we have our WebSocket, and it allows us to send messages back and forth. Like so. Um, the reason why we're using Redis in this case is so that if we have multiple instances of the server running, say we have like 5 or 6 instances of the server running, they can all connect into that Redis channel and all notify any clients that are connected to them via a WebSocket. And that is Vapor for the most part. So we went over a lot. I tried to cram in a lot here. We talked about models, migrations, HTTP, WebSockets, authentication. I want to quickly highlight the Vapor docs. It's really obviously a great reference if you're trying to use Vapor. There's documentation for Fluent, the ORM, Leaf, which is actually created to it's used to render HTML, Redis, and then advanced topics such as middleware, WebSockets, sessions, etc. Let's jump back into the deck for a minute. So now I just want to briefly touch on why you want to use Vapor. So as a backend engineer, why do you want to use Vapor? One, it's written in Swift. So Swift is an ultra modern language, really driving the industry right now in terms of how it's architected, how it's used, especially around protocols. Of course, it's a compiled language. It's a blazing fast language. So because Swift is so fast, so is Vapor. And we'll look at some metrics in just a minute for that. And there's a very passionate community around it. It's a small community right now. Obviously not as big as some other frameworks such as Node, but nonetheless, a very passionate community. And it is stable. Like it's been around since 2016, so it's gone through a lot of changes over the years, but especially now with the addition of async await and WebSockets and Redis, like you can use Vapor for essentially anything. So just taking a look at some metrics, right? So speed for plain text requests. We have Go at the top, and then we have Vapor in second place, even above Node and Django and Spring. So again, Vapor super fast. When we're talking about JSON requests, Go is still in #1 place, followed by Node and Express, and then followed by Vapor. So Vapor takes third place here, still super fast. And then in terms of SQLite requests, so actually querying a database, Vapor comes in second, again, after Express and Node. So some really great metrics. As you can see, in all 3 categories, you know, there are of course more categories that should be considered, but Vapor is extremely fast in all categories. We can quickly talk about some drawbacks. So again, it's relatively new. It is stable, but there are lots of changes coming down the pipeline always. Like async await was a huge change that required a lot of refactoring old like legacy future and promise-based backends. Relatively small community, so it's not always the easiest to find answers to questions. But there is like a Discord server that's very active, has a lot of contributors, and overall the code base, like the frameworks themselves have a lot of contributors. I think the most painful one is probably the lack of third-party integrations. If you want to integrate with a third-party backend, most likely they're going to have integrations for Node or Python or Java, and that just, it really doesn't exist for Vapor. So that's one of the main pain points. But there are some frameworks that are available, including frameworks for GCP, AWS, and GraphQL. Some companies using Vapor, you know, these, you're probably not familiar with a lot of these companies, but HelloFresh, I personally use HelloFresh, and they do use Vapor to some extent in their backend, which is pretty cool. So it does have some amount of mainstream adoption, though it's still gaining a lot of traction. There are some alternatives, like I mentioned earlier, such as Perfect or Kitura. I believe these aren't, the communities really aren't as active in these, and development has really been falling behind as compared to Vapor. Vapor is certainly the most popular framework for server-side Swift, and definitely the most mature. Here are some just generally useful links that you can use. And then, yeah, in conclusion, you should start using Vapor today. It's a great backend. I've had such a great experience with it. Any backend engineers or even iOS engineers, I highly recommend check it out.